Euclid's book 2, proposition 5 says that given a line segment AB, if we cut it into two equal parts or two equal segments and unequal parts. So here AC and BC are equal parts and AD and DB are unequal parts. Then AD by BD plus CD square is equal to CB square. So let's see how we can show that. So remember, the proposition says the rectangle on AD plus the square on CD is equal to the square on BC. So that means we have to create a square on BC. Let's do that. Let's draw a circle at C. Intersection points. Circle, circle, intersection point, and a line. Now none of these intersection points we are interested in. We are only interested in that line, and that line we have to cut it in such a way that it equals CB. Intersect. So CE is equal to CB. Completing the square. Again we draw circles, intersection points, segment, segment, and we have to join CE as well. But for the moment we will leave this line itself. Now we will join the diagonal BE, and now we have to draw a line through D parallel to CE. So let's do that. Let's draw a circle, intersection points, and each. Now we don't require this circle. Now the intersection point of these two we mark it, and now through H we draw a line parallel to AB. Okay, intersection point, and we draw a line. This line is parallel to AB. Let's mark this point of intersection of this line and BF. We have to connect this. So draw a circle, intersection point, segment AK, and join all these segments. And now let's remove this and this circle. Okay. So now what does the proposition say? This rectangle plus this square is equal to BC square. So AD by BD, that is what this rectangle is, plus CD square is equal to CB square. Yes. So let's take it step by step. So visually itself we can see that this is going to be equal to this rectangle. Rectangle CH will be equal to rectangle HF. Why? Because they are complementary parallelograms. This is a square, and CLMB is equal to AKLC. Why? Because C is the midpoint. So this parallelogram or rectangle is equal to this rectangle. This parallelogram is equal to this parallelogram, or this rectangle is equal to this. So this plus this plus this plus this would be equal to what? Would be equal to this plus this. AKHD plus this square will be equal to CB square. That is, the area of this figure would be equal to the area of this figure. So that is proposition 5 of book 2 of Euclid's Elements. Again, if you notice, if I move this around, it will always be true. Whether I move this, whether I move this. C I can't move because it's supposed to be the midpoint. Yes. So we can't move that, but we can move this, we can move this, and this will always be consistent or true. Again, let me remind you, providing a link to a PDF book which describes all these propositions of Euclid's elements. That's it for now. Bye.